Here we're going to finish making the connection between all four representations of a function. A function is really just a rule or an equation. We're going to go from that to words, to a table, and to a graph. We're also going to be given each of those. We're going to start out with each of those and go to the other three. We're going to start out with words and go to an equation and a table and a graph. We're also going to start out with a graph and go to each of the other three. We're going to see that each of these is really just representing the exact same information in a different way. All right, so on the first one, we're starting out with the equation y equals 2 times the number minus 3. We could write it like that. I chose to write it a different way. I'm going to say the output, the y, is 3 less than double the input. So 3 subtracted from 2 times the input would give us the output. Again, that's just one way to write it. You could write it a bunch of different ways. When we represent a rule as a table, we're going to set up that table with a list of x and y values. We're going to substitute in for x to get our y values, and then we're going to write the table of ordered pairs. All right, so again, we're using that equation to generate these points. We're just going to plug in values for x and figure out what the corresponding y is. So our first one, we're going to plug in 0 for x. That would give us 2 times 0 minus 3. That would give us 0 minus 3, which is negative 3. So our y value for that x value is negative 3. That gives us the order pair 0, negative 3. Actually, let's just go over to the graph right now just to make that connection. We're going to plot each of those points, each of the ordered pairs on the graph. We'll connect the dots to form a line, and we're going to check to make sure that our slope actually matches our graph. We'll do that at the very end. So let's just plot this first point, 0, negative 3. Alright, the second point, we're really just picking whatever x values you want, so let's make it as easy as possible. Let's just plug in 1. 2 times 1 would give us 2, and then 2 minus 3 would give us negative 1. So the y coordinate is negative 1, and that gives us our second order pair, 1, negative 1. The third point, again, make it as easy as possible. Let's plug in 2. We plug in 2, we get 2 times 2. That's 4. 4 minus 3 would give us 1. So 2, 1 is our third point. And that gives us our line. And now we just want to check to make sure that our slope, the slope of this graph, really matches our slope in here. That's a slope of positive 2. That should be going uphill. And we're going from left to right. You can see that's an uphill climb. So that's a positive slope. That does match up with the slope in our equation. You can also see that the y-intercept, that negative 3, matches up with the y-intercept in our equation. Try that one on your own. Pick up with a video on the next page. Here we're given a sentence that we're going to translate into an equation and then make a table and graph those points. Y is equal to 3 more than 2 times the number. 3 more than, that's one of our phrases that tells us to switch, so we're going to switch the 2 times the number and the 3 more than the adding 3. So it's 3 more than 2 times some number, 2x plus 3. Again, we're going to set up our table of x and y values. We're going to substitute in for x to find the y values, and then we'll write the ordered pairs. After we have those ordered pairs, we're going to plot them on the graph, connect the dots, and again check to make sure that our slope matches up with our equation. So again, let's plug in some easy values. Let's plug in 0, 1, and this time I'm not going to plug in 2 because I see that if I plugged in 2, I would do 2 times 2, that would be 4, plus 3 is 7. That unfortunately would not be on this graph. The graph only goes up to 6, so I'm actually going to plug in negative 1 as my third x value. When I plug in 0, it's 0 times 2, that's 0, plus 3, that would give us 3, so our first point is 0, 3. The next point we're going to plug in 1, 2 times 1 is 2, plus 3 is 5, so our second point is 1, 5. And our third point, plug in negative 1, 2 times negative 1 is negative 2. Plus 3 would give us a positive 1. So negative 1, positive 1. And those are 3 points, giving us this line. Again, we want to just check to make sure that our slope matches up. That's going uphill. That's a positive slope. And the number in front of our x should be a positive number. It's a positive 2, so that makes sense. You can also check the y-intercept. That's positive 3, so it should hit at positive 3. And it hits our y-axis at positive 3. Again, try that next one on your own, and pick up with the video on the next page. Here we're going to be given a table, so we're given a list of ordered pairs. You could be given this in 2 different ways. You could just see this as a list, or you could see this as an x and y table like this. Either way, they're really giving us the set of ordered pairs. The graph is going to be the easiest one to get to. We're just going to plot those points, connect the dots, and we're going to check to make sure that the slope of this line, these 3 points plotted, matches our equation that we get. So we're going to just plot those, -1, -4. So we're just going to plot those 3, -1, -4. So we just need to plot those 3 points, -1, -4, 0, -1, and was it 2, 5? Those are our 3 points, giving us this line. Writing the rule is a little bit trickier. We need to find the slope and the y-intercept. So we're going to find the change in y over the change in x, or the rise over run. We're really just going to count. I'm going to count from this point up to that point. How many spaces is that going up? It's going up 1, 2, 3, 4, 5, 6. Notice I'm not counting along the line at all. I'm just counting straight up to that level. So going up from here to there, we're going up 6 spaces. That's our rise. And our run is 2. We're going just over 1, 2 to the right. So our rise over run is 6 over 2, giving us a slope of 3. The y-intercept is wherever this hits the y-axis, it's at that point, that's -1. So the coordinate is 0, -1. Really, the y-intercept that we're going to be using is -1 or -1. That gives us the equation y equals 3x minus 1. That's our final equation. That's the rule. So we first found out the rise and run. That tells us our slope. Then we find out the y-intercept. That tells us the second part of our equation. Really, that's all we need. We need the rise over run and the y-intercept. Then we substitute those in where they're supposed to go. The slope goes before the x. The y-intercept goes after the x. That helps us write our equation. And then we're going to make sure that this rule actually works for all of these points. So when we plug in an x value of -1, do we get -4 for this rule? So when we plug in -1, we'd get -3. -1 would give us -4, so that makes sense. Let's try it for one more point. Let's try it for 2. If we plugged in 2, we do 2 times 3, that would be 6. -1 would give us 5, which makes sense. That's the y value that we wanted to get. Now we're going to translate that into a sentence. So I'm going to say this as y is 3 times x minus 1. The last example is given a graph. The first thing we want to do is just pick out 3 points that are actually on that line. Pick out the x and the y values, and then write them in a table as ordered pairs. So I picked out 3 different points on that line, 0, 1, 1, 3, and -1, -1. All 3 of those are on that line. -1, -1, 0, 1, and 1, 3 are those 3 points. And I'm going to do exactly what I did on the last one, where I tried to find the equation of that line using the slope and the y-intercept. I'm going to find the rise over run and the y-intercept, and that's going to help me find the equation. All right, the slope, I'm going to count up from 0, 1 to 1, 3. I'm going up 2 spaces and over 1. So the rise and run is 2 and 1, or 2 divided by 1, which just gives me a slope of 2. The y-intercept is this point here, 0, 1. So our y-intercept is positive 1. That gives us our equation, 2x plus 1. So again, the slope goes in front of the x, the y-intercept goes after it. That tells us our equation, and we can make sure that this actually works for all of these points. Let's try -1. If we plugged in -1 in for x, 2 times -1 would give us -2, plus 1 would give us a -1. So it does work for that point. It's going to work for all of those points. Again, that's just to check to make sure that your rule actually matches up with the points that you're given. Changing that into a sentence, I'm going to write that that is y equals, or is, 1 more than twice the number.